Welcome back, Focus Learners, to another explainer. Right into it today. We are tackling a huge bottleneck in the world of AI-assisted coding, and yeah, I'm talking about hallucinations. You know the drill, right? You watch an AI agent confidently write a block of code, review it, and then proudly declare it perfect, only for it to immediately crash your app. Well, today we're exploring a seriously cool new tool called the pair. It structurally solves this exact problem by taking away the AI's ability to grade its own homework. It's a fascinating architectural shift, so let's unpack exactly how this two-agent system works.
Okay, let's dive into this. Here's the roadmap for our explainer today. We'll start with the AI self-review problem, then move into the dual-agent solution. Check out cognitive transparency in action, dig into the guardrails and Git integration, and finally, figure out if the pair is actually right for you. We're covering the high-level concepts and the gritty technical details, so let's get to it.
First up, the AI self-review problem. Why does relying on a single agent fail us so often? There's this quote that just absolutely nails the issue. That's not a review. That's a spell checker proofreading its own typos. Think about it. When you hand a complex task to a single AI agent, like, hey, write this feature or fix this bug, that one agent is doing the planning, the executing, and the reviewing. Because it's the exact same model operating in the exact same context window, it is literally blind to its own hallucinations.
So the crucial takeaway here is that the same model making the mistake cannot reliably catch it. In practice, you know what happens? These single agents will just rationalize their bad output into existence. If it writes a flawed function and you ask it to review that same function, its internal logic will basically just justify the flaw instead of actually fixing it. It just stubbornly waves through its own errors silently. It's a massive structural flaw in single agent workflows.
Which brings us to the big question driving this whole explainer. What if one agent plans and an entirely different agent executes? What if we completely split those responsibilities so they don't share that same context? Let's see how this changes the game.
Section 2. The dual agent solution. Let's look at this structural separation.
So the pair actually solves this by running a mentor and an executor agent in parallel. It's a sleek, local-first, native desktop app built on Tauri 2.0 and React 19, and it runs these two distinct AI agents simultaneously to force mutual cross-checking. And the best part? It's not just some clunky Python script you have to wrestle with. You don't even need a package manager. You literally just go to their GitHub releases and grab the pre-built binary from macOS, Windows, or an app image for Linux. Super accessible right out of the box.
And this brilliantly illustrates the core architecture in practice. We've got two distinct roles. First, the mentor agent. Now, this agent is strictly read-only. It plans the approach, reviews what gets produced, and validates the output. But crucially, it cannot write files or run commands. Then, on the other side, we have the executor agent. This guy is hands-on. It writes the code, fires off the bash commands, and then submits its work back to the mentor for review. Because the mentor can't physically touch the code, it can't rationalize bad output. It is forced to objectively judge what the executor delivers.
The feature set backing this up is honestly super robust. You get tunable reasoning controls for each role, so say planning is your bottleneck, right? You can crank up the thinking effort for the mentor while keeping the executor fast and light. You can also attach project-specific skill files so you don't have to rewrite prompts every single time. Plus, it has seamless session recovery. If you close the app mid-session, everything is right there when you restart, which is a total lifesaver for long, autonomous refactoring tasks. Oh, and as of version 1.4.3, the UI has complete CJK coverage, meaning full localization for Chinese, Japanese, and Korean developers. Moving on to Section 3, Cognitive Transparency in Action. This is where we get to actually see the AI think.
Let's move to Seer and see how this builds on those recent v1.4.0 updates to create a truly observable system. Usually, you hit enter on an AI tool and just stare at a spinning wheel, right? The pair gets rid of that black box anxiety completely. They use intent chips, which are these cool little live status indicators showing if the agent is analyzing, coding, reviewing, or handling an error. Underneath that, you have tool call steps, expandable visual blocks showing the exact bash commands or file writes the executor is trying to do, and finally, reasoning events. The app literally captures the real-time logical steps straight from the AI's internal blocks and renders them on screen. You are literally watching its brain work in real time.
Section 4, Guardrails and Git integration. Because if you're giving an AI write access, you need some serious peace of mind.
Giving an autonomous AI the keys to your workspace is no joke, so the safeguards here are absolutely crucial. Let's talk about the number 20. This is your primary defense. It's a strict, flat budget of 20 iterations per run. In older versions, they tried this overly complex, adaptive budgeting system based on file counts, but they scrapped it. Now, it's just a hard cap. It ensures the AI respects your intentional limits and doesn't just infinitely burn through your API credits.
Then we have 50. This is the step cycle limit per turn. Say the executor gets confused and enters an infinite loop, just stubbornly hammering away at a failing bash command over and over. This safeguard kicks in. After 50 cycles in a single turn, the app just terminates the process, so your CPU doesn't melt down.
And point 8. This one is super fascinating. It's the confidence score threshold. When the mentor reviews the executor's work, it doesn't just give a simple pass or fail. It actually provides structured issue lists, reasoning, and a specific confidence score. If the mentor's verdict is a pass with a confidence score of 0.8 or higher, it automatically finishes the iteration and moves the session forward. A brilliant metric for automated quality gating.
Also, you never have to guess what files those iterations actually changed, because the pair has built-in Git tracking. You just click on any changed file in the detail view, and it pops open a side-by-side Git diff of your staged and unstaged changes. You don't even have to drop into your terminal to run Git status. It visually tracks the whole shebang for you.
Section 5. Is the pair for you? Let's talk practical deployment and limitations. Now, what's really interesting about this slide is the flexibility. The pair is completely provider agnostic. You can use Claude Code, Codex, OpenCode, Gemini CLI, and here's the kicker, you can mix and match them. You could totally use Claude's top-tier reasoning for the mentor agent and then use Codex for fast, cheap implementation on the executor side. But, fair warning, doing that means you're juggling 2 separate authentication flows, 2 different rate limits, and 2 separate billing setups. Very powerful, but for sure adds some complexity.
We also need to objectively look at the limitations here. This tool is an absolute dream for long, autonomous refactoring sessions where you just want to step away from your desk. But for quick, short, interactive tweaks, the orchestration overhead is honestly overkill. Also, remember this is just an orchestrator. You still need your own working AI CLI credentials. And please, be careful. Full automation mode grants workspace scoped permissions. The executor can and will run commands in your directory, so maybe don't point it at a folder full of live production secrets, right? And keep in mind, it's still a young project, sitting at around 304 GitHub stars right now, so you might hit a few rough edges.
But a massive point in its favor is the privacy aspect. Its local-first architecture ensures that literally zero data leaves your machine beyond what is sent to your specific AI provider. There's no middleman server creeping on your codebase. Between that privacy guarantee, the session recovery, and the strict mentor-executor separation, it's a highly defensible setup for serious development work.
Which leaves us with one final provocative question for you to consider. Are you ready to stop letting your AI grade its own homework? By forcing this structural separation between planning and execution, the pair actually brings genuine, objective review back to autonomous coding. If you are sick of AI hallucinations slipping through the cracks of self-review, this might literally be the game changer you need for your next big refactor. Thanks for joining me on this explainer, focused learners. Get out there, download the app, and see what a real 2-agent system can do for your codebase.